بسم الله الرحمن الرحيم رب زدني علما.
So let's move to the configuration part. In terms of configuration here, I will try to simply set up one simple GRE tunnel here. So as per my topology here, we do have these routers as per my topology. So the default topology where the router 1 and the router 2 are acting as my remote sites, and the router 5 is simulating my internet. And here we will be quickly moving on with the configuration. So starting with the router 1 side. So before we go ahead, the prerequisite are the same. We need to make sure that we do have a LAN interface, which is connecting F0 by 0, connecting on the router 1, and S1 by 0 interface connecting to router 5, that is your internet. Same way on the router 2, we do have this basic IP addressing here as per the topology. So this is the public IP and this is your LAN interface. And we need to make sure that we do have reachability to the public IPs. So the prerequisite to configure any VPN, whether it is a GRE or any VPN, these public IPs should be reachable. In the real networks, they are reachable. But again, here I'm using a default routes on both the ends, which goes to router 5, and the router 5 knows both the networks. In the real scenarios, this will be your real internet, where there is a BGP protocol which will provide end-to-end reachability. Again, that is the job of the service provider. We don't need to really worry on that. When you are connecting to internet, means you are actually reachable to the public IPs. So let's go to the configuration part. We'll start with the router 1 side. On the router 1 side, simply we need to go and create one tunnel interface. Any number you can use. I'm using 1, 2. And this is a locally significant number, so it can be same or different on the opposite side. Now, once we create a tunnel, we need to assign a logical IP address to this. Even though the router 1 and the router 2, they are not directly connected. So we'll be creating one logical interface, which is going to connect. In my case, let's say I'm using tunnel 12. And this tunnel 12 interface should be assigned with some IP. Just like when you connect two routers, there must be an IP from the same subnet in order to connect. The same way here, the tunnel interface is going to simulate that logical connection between the two endpoints. So you have to give any IP address. It's as per your own IP addressing scheme, as per your company network, you can decide. Any private network, not public here. So let's say I'm using 10.0.12. network. And now we need to tell where is the tunnel, where the tunnel exactly starts. So it starts here and where it exactly ends. It ends on the public IP of the router 2. So we need to specify these options here. So interface tunnel, and then we need to say tunnel source. Now the source can be either you can define the interface name, because this is my source from the router 1. This is my destination. So either I can tell the source interface name or I can tell the IP address. Both are correct. You can use any one. So we say tunnel source 15001, or you can also define the name of the interface. Tunnel destination cannot be interface. It has to be an IP address because it is a remote device. Done. That's it. And the same thing, we need to go back to the router 2. On the router 2, we need to create a tunnel. And then on the tunnel, assign the IP. The IP should be from the same subnet, what we have configured on the router 1. And then tunnel source. This is the IP, local IP. And the tunnel destination 15001. Finish. Now that's it. Very simple configuration here. Now, in terms of verifications, we can go ahead and verify with a command called show IP interface brief, where you will see there is a logical tunnel interface which will be created. And if the configurations are correct, if the source and the destination addresses are reachable, then you should see this tunnel interface should be up and up. And alternatively, if I try to ping to the router 2 tunnel IP, so this is 1, I'm trying to reach router 2. So you should see the reachability. Now this looks as if there is a router 1 connects to router 2 on 10.0.12. subnet. So this is a kind of a logical tunnel or the logical WAN link or the logical connection we are trying to establish between the two endpoints. So this is the tunnel interface, and once you do this, now the last part you can implement some routing protocol on the top of it, because now even though the tunnel is established here, the WAN interfaces are able to ping, but still there is no LAN to LAN communication. If you try to ping to the gateways, there is no communication here. And the reason is simple. The router do not have a route for 192.168.2. network. That's a simple thing. So if you check the routing table, so we do have the default route, but that goes to router 5, and router 5 don't know where is 2. network. So to provide end-to-end reachability, we need to configure a routing protocol, just like we configure routing. So LAN to LAN communication, how we do? So we got a WAN connection, we got a LAN connection. So LAN to LAN communication is only possible when you implement some kind of routing end-to-end. So here let's say any routing protocol you can run, EHRP, OSPF, RIP, whatever the protocol, it's up to you. Let's say I'm going to advertise my LAN interface, and I'm going to advertise the WAN interface. What is the WAN interface? I'm using 10. network, the tunnel interface. Advertise your WAN, advertise your LAN. And the same thing, we need to do it on the router 2 as well. Router EHRP. Advertise your WAN interface and advertise your LAN interface. Now here you can see once I finish the WAN interface advertisement on both the ends, you will see the new neighborship established between the router 1 and the router 2. There is a show IP EHRP neighbors to verify the neighbors. You can see the neighborship is up. If you verify the routes, you can see the routing table, the exchange, just like a normal routing. And finally, if you try to check the end-to-end reachability here, if I just go and say repeat, or just generate the packets from 1.1 to 2.1, you can see there is an end-to-end LAN communication is possible. So if you see here, the concept is very simple and straightforward configurations. So we are creating a logical tunnel interface. At that tunnel interface is going to be simulating your logical point-to-point connection between the two endpoints. And once you build the tunnel, the WAN will be up. And to provide end-to-end LAN communication, we will be configuring some kind of routing. You can use any routing protocol to do that. And once you implement the routing, you can see the communication process starts end-to-end.